Hi everyone, welcome to a new video. In this video, I am going to discuss with you guys one Golang interview question. So any further delay, let's get started. So I have already uploaded couple of videos on this topic. If you want, you can watch that videos as well. I will add the playlist link in the description. This video, what we are going to learn, like how you can handle race condition in Go concurrency. You have to first know what is rest condition. A rest condition happens when two or more concurrent threads or coroutines access the same memory and at least one writes and the accesses are not synchronized. Okay, what do we mean by this words like not synchronized or at least one writes? I am giving an example, like there is a one variable x and that particular variable x is accessed by multiple coroutines. Okay, and any one of that coroutine is doing write operation, like we are incrementing our x by one with the one coroutine. With the help of any one of the coroutine, we are incrementing our x value by 1. Okay, so as all the coroutines are executing concurrently, it means like they are all the coroutine executing at the same time, so it may possible that incrementation or like that modification did not reflect in other coroutines. That can happen because they are not synchronized. What do you mean by synchronized? Synchronized means like they are, if they have multiple methods or function, all are execute one by one, like first method or function will execute, then the second function, then the third function. Like after the second function will finish, then the third function will start. It is not possible like we haven't finished the second function and the third function got started. That is not possible. Okay, first function will finish and the second function will finish, then the third function will start and the third function will finish and then the fourth function will start. This way the synchronization works, right? But in case of asynchronization, means they're not synchronized. In asynchronization, all the coroutines, all the threads will execute at the same time, means they are executing concurrently. Okay, so whatever like changes we are doing, there is no guarantee that same changes will be reflected in all the coroutines, right? If all the coroutines are doing read operation, that is totally fine, right? If there is no write operation, means we are not doing any modification on the variable, that is totally fine. But if there is any at least one write operation, it means that there is a chances of race condition. That's why there is two main thing you have to remember, like there will be a write operation. The second point, all the accesses are not synchronized. See in Go how we can create a race condition. Although here we will do intentionally, but in maximum cases race condition happens accidentally. Okay, like totally unintentionally. Okay, so now what we will do, we will first see when a race condition can happen. Okay, suppose there is a variable count and we are incrementing the count variable in every coroutine. Okay, so I'm just writing down the same, okay, so that you can easily visualize like what I was trying to explain you. Like we have a function, okay, in that particular function we have a count variable 0. Okay, so now we are like launching 1000 coroutines. Okay, how you can launch a coroutine, right? With the help of Go keyword. We have to invoke this function at the same time. So now we'll do count plus plus. Okay, and also there is a need of wait group. Okay, but why? Because we need to wait till all the coroutine completes its execution. To do wait group, to add, like whenever a new coroutine will be added, then it will be increment, like it will be add again 1, then the second coroutine will add, then again will do go add 1. Okay, and here we will do defer increment at 1, right? And here at the end we will wait for all the coroutines to finish its tasked, right? We'll print our count variable. So now, why I am saying it's a race condition code. Go run dot. Okay, we are running something. Okay, and it's not printing anything because I haven't called this particular function. My bad. Okay, so now we can just run this one. So now it's like 984. Like, what was the expected output? 1000, but it is giving me 984 without any error. So like, it's not giving me any error, but it's not giving me the expected output. So there is some chances of bugs, right? So now if we again run this one, so now it's giving me 995. Like, there is some discrepancy, right? So okay, so we have to understand this thing. Like, this particular code is not giving me any error. Even the output it's giving me, that is not even same. It's like changing. Okay, if I again run this one, then we are again getting another output. So there is chances of getting some bugs. Okay, if you see, what was the definition of race condition? Like, there will be at least one write operation and all the accesses are not synchronized. Obviously, we are working with Go routines. If we are working with Go routines, it means there should be like asynchronization or like no synchronization concept is applied here. Okay, because in Go routine we know all the Go routine executes at the same time or like concurrently. Okay, and if the coroutine is executing concurrently and if the coroutine is incrementing our count, okay, it means there is a write operation. Okay, although there is a like at least one write operation, but all our coroutines are doing some write operation, that is also okay. Okay, minimum one, it like compulsory. Here may possible sometimes we are doing some write operation in Go routine and that new updated count value was not visible or like somehow was not reflected in another Go routine implementation operation on the old value, then there may be chances of getting the wrong output. The count value got changed to like 2 to 3, but the next coroutine, as all the coroutine is like executing concurrently, the third coroutine or like fourth coroutine use the old count value, not the updated incremented count value. Okay, so that is what is happening internally. It's a small code, but in like production level or like in real world projects, there will be lots of lines of like 10,000, 50,000. So that in that case, it will be hard for us also to detect the race condition. Okay, although here like we are intentionally like creating a race condition, that's why like we know like there is a race condition line number 23, but that will not be the case when we are working or like we are dealing with multiple projects or like real world projects. Okay, so now in Go, to solve this problem, we have another command that we can use. We have go run and -race. You have to memorize this command. Okay, then the Go file name you have to mention. Okay, main.com. This is the Go main file. Okay, if you run it, then you will see it's saying like found two data race. Okay, means they have some race condition, okay, that you have to solve. Okay, so it will be really helpful for you to understand or to check or to verify the race condition in your code. Okay, it will even provide you the line number as well. Okay, this is the line. Okay, so it's really a helpful comment that you can use. So suppose you do not have this main.go file. Okay, you have some test file. Okay, quickly we can create another test file as well. Okay, suppose I am copying this same function. So I think you already know the concept of like test, like this method name should be like test increment count. You have to also pass like the .t. Okay, you have to import this one. Equals to 0 is not like compulsory. I'm just giving an example. Okay, so now here it's a test file. Okay, So suppose here also the same like race condition we have, right? Like you can detect. Okay, like you cannot use the same command. Okay, the same command we are using for this main.co, the same normal core file, the command we are using to identify the rest condition, the same command you cannot use for the test file as well. For that we have another name you have to mention. Okay, this is a test file. Now if you run this one, it will give you the same thing, like there is some race condition. Okay, so many things it's saying, like yeah, line number 16, this like producing the race condition and all. So yeah, you have to remember these two comments. Okay, so there have 2-3 ways that you can follow to avoid the race condition. First, you can use sync.Mutex, acquire the key. Okay, when whatever operation you are doing, you can do. Okay, when you are done with the operation, like when you have completed all the operation you want to perform, then you can just release the key with the help of unlock method. Okay, first you have to declare the variable like mutex, mutex. Okay, now you have mu. Okay, and you have to use this variable. So you have to acquire the lock. Okay, when you will be done with the operation, then you have to release the lock. Okay, mu dot unlock. This is what you can do. If you now open the terminal, then go run -dot, and now it's giving me 1000, the correct output. That is what the expected output as well. So now if we do go run -race, then main.go, if we do, then like it is also giving me 1000. Okay, so it means there is no race condition. So this is one technique that you can follow, like sync.Mutex, like lock unlock, like you have to acquire the key, like your lock method will be helpful for that. You want to release the key, then you can use mu.unlock. Okay, these two functions you have to remember. Now we'll discuss another way, that is like sync/atomic package. We have that atomic like add int function we have in atomic package. Okay, Peter will just show you the example, that will be also helpful. So we can just remove this one, there is no need of this. Okay, accidentally I just removed the white group, sorry. Atomic, okay, atomic dot add int. Okay, so basically it's like I think in 32 it's fine. So in 32 you can mention and then count with by 1. Okay, and also like one thing you have to do, like here you have to change this count variable, because like int 32 no, so you have to 32 only. So now I think yeah, you have to use you have to import this package sync/atomic. In the atomic you have multiple methods, it's not like only you have add int. If you just quickly check, then you can see there's loads of method we have. You can obviously use according to your requirements. Okay, this terminal you can check. Okay, like I'm running it now, it's not giving me any race condition. We can just run quickly like that. So it's also like go run dot, and it's giving me the 1000 expected output. Okay, these are two easy ways that you can follow. Okay, another way you have using channels. Okay, that is also not like hard thing, that is also easy. Just removing everything, that is not required. Okay, so like you will have the like my chan, you will have a channel, and we will take a buffer channel like 1000. Okay, so basically what we will do now, like we will start a coroutine. Okay, we'll start a coroutine, and we'll like you have to start it, not we invoke the same time. So okay, in this coroutine we'll do some operation, but before that I just wanted to show you what we'll store in our channel. Okay, so like suppose you have a for loop channel, my channel you will store 1, you will store. Okay, after storing you can just close your my channel. Okay, and also like you also need the void group. right? Wait group will be important. Wait until all the coroutines finish its work. Okay, so I think it's clear up to this. Okay, you have to close and then you have to like wait for this as well. Okay, and then you can just do fm the like count variable, we can say. But okay, let me first see what we can do here. So basically I haven't declared the count variable actually. Let me first, okay, we can also do count is equal to 0. Okay, so now you have that range, okay, then range my channel, and then what you can do, you have this C, right? So you are storing one only. So this count, okay, like it means you in every execution you are like incrementing or count by one only, because you are storing one in your channel. Okay, this way you can do. Okay, like you have the channel, okay, it's a buffer channel because the size of the buffer channel is 1000, and we have the void group. Okay, we have to do another thing, like I just, you have to add one. Okay, and then you have to like you have started a go routine. Okay, you started a go, you have to do void group dot add. Whenever you start a go routine, you have to do void group dot add. Okay, and in your particular go routine, when all the operation will be done, then you have to do like void group dot differ. Okay, because like it will be it will increment by one. Like add means one, that means it will decrement at one. Okay, let me see if there's any error, or like we are good to go. If there's any error, that is also fine. Okay, I think we need to do something. Really, I haven't print anything, that's why the problem comes. Yeah, okay, it's working. It's giving me 1000. We can also run like code. Okay, it's also giving me 1000. I mean, it's working as expected. So happening in this particular like code. Okay, so basically we have a main function, and the particular main function we are calling this particular function. The main coroutine is like executing here. Okay, so here main coroutine is starting another coroutine. Okay, so what we want, like our main coroutine should wait for this particular child coroutine that we have created. Okay, how we can make sure that, for that we are creating this void group. Okay, and we are adding this one, and when we will do defer void group dot done, then this particular the one we have added here, it will be in decrement by one. Okay, and then when it will be become again 0, like all the coroutines when finish its tasks or all the operation, then it will become 0, because the same amount of coroutines we are launching and then we are adding one, and in the same, in our coroutine we are decrementing this one, so at the end there will be 0. So this particular void group will wait for all the coroutines to finish its tasks. Okay, and it will tell your main coroutine, okay, please stop, like our child coroutines are still in progress and they need to finish their tasks, so please wait. Something you can think like this. Okay, so now here we are using buffer channel. If you use non-buffer channel, then there will be chances of blocker. That is also we can handle with the go routines as well. But okay, for simplicity, here what I am using a buffer channel. Okay, if we have a buffer channel, and then here we are initializing our buffer channel and we are inserting one, and in this particular coroutine we are accessing our channel data, and also we have to close the channel. It is also important thing to remember, whenever you are working with a channel, you have to, or like you must close the channel. Okay, and then like we are doing void group the void, like it will wait for all the coroutines to finish its tasks, and then at the end we are just printing our count. Okay, so these are the three methods that you can remember to avoid a race condition. Thanks for watching the video. If you have any doubts, any question, please let me know in the comment section. I will be happy to answer all of your comments. So thanks for watching and see you in the next video. Bye bye.